Assalamualaikum warahmatullahi wabarakatuh. Today we're gonna present a case study which is part 1. Our title is Basic Component of Gas Turbine Power Plant. This is our group members. First of all, Anil Asraf bin Muhammad Isnin. The registration number is 01DKM18F2017. Next, Muhammad Afiq Ikmal bin Muhammad Zulkifli. The registration number is 01DKM18F2018. Next, Alif Akmal bin Sharudin. The registration number is 01DKM18F2019. We are from DKM5A. And our lecturer is Encik Kirizam bin Makhir.
Hi, Assalamualaikum. My name is Alif Akmal bin Sharudin. My metric number is 01DKM18F2019. I will explain about introduction to gas turbine power plants. Okay. The demand for gas power plant is increasing because of certain benefits. Natural gas is used as a fuel. Other fuels can be synthetic gas, just like steam power plants, in which operating fluid is water and steam mixture. In gas turbine power plants, air mixture is used as a derivative fluid. In a jet engine, one side as a turbine and one side as a compressor. The air is enter in the compressor. It mixes up with the fuel, and then it eject it from the turbine. The turbine converts the pressure and velocity into electrical power through the generator. And a major problem in operation of gas turbine power plants that when the fuel is being ejected, its temperature is 400 to 500 degrees, which can cause atmospheric pollution, and a lot of energy is wasted. Because of this wastage of energy, the efficiency of normal gas turbine power plants and open cycle gas turbines is around 20 to 25%, which is way less than its potential. Even steam turbines have greater efficiency than this. The compressor and turbine are on the same shaft mostly. Compressor drives and compressor the air 15 to 30 times, and then the fuel is mixed, and when that mixture passes through the gas turbine at high pressure, the energy is converted. The energy required to drive the compressor is delivered to the compressor from the same shaft through the turbine, which means the major portion of the energy is utilized by the compressor to drive, and the rest of the energy is utilized in the turbine. The compressor has multiple stages: low pressure compressor, intermediate pressure compressor, and high pressure compressor. The compressor is the opposite of the gas turbine. The turbine uses kinetic energy and converts it into rotational kinetic energy. However, the compressor uses the rational kinetic energy to convert it into potential energy of air and fuel mixture.
Okay, my name is Muhammad Afiq Ikmal bin Muhammad Zulkifli, and my metric number is 01DKM18F2018. Here I will continue for the working principle of basic component of gas turbine power plant. There are three basic components, which is compressor, combustion chamber, and turbine. Okay, next, there are three basic components of gas turbine power plant. So first of all, compressor. Compressor is draws in air and compress it. Next, combustion chamber. Fuel pump in and ignite to burn with compressed air. Next, turbine. hot gases converted to work can drive compressor and external load. Next, for the working principle for compressor, first of all, the compressor withdraw air into the engine, pressurize it and feed it into the combustion chamber at speed of hundreds of miles per hour. Compressor can be divided into two types, which is radial or centrifugal flow. Next, axial flow. Next, for the working principle for combustion chamber, the combustion system typically made up of a ring of fuel injector that inject a steady stream of fuel into combustion chamber where it mixes with the air. The mixture is burned at temperature of more than 2000 degrees Fahrenheit. The combustion produces a high temperature, high pressure gas stream that enter and expand through the turbine section. So, for the working principle for turbine, the turbine is an intricate array of alternate stationary and rotating aerofoil section blades. As hot combustion gas expands through the turbine, it spins the rotating blade. The rotating blade performs a dual function. They drive the compressor to draw more pressurized air into the combustion section, and they spin a generator to produce electricity. Next, for the gas turbine system, there are three gas turbine system. First of all, air system. Air intake are located high up and multiply filter. Next, exhaust discharge out stack. So next, fuel system. Uses either DFM or JP5. Last but not least, lubrication system. Supply bearing and gears with oil. Okay, next, gas turbine accessory system. There are two gas turbine accessory system, which is starting system and power transmission system. First of all, we're going to start with the starting system. Starting system is to get compressor initially rotate, horsepower air can use electrical also. Once at certain RPM, fuel injector and spark ignite. So next, for the power transmission system, reduction gear used to transfer torque. With split shaft, turbine can run at different speed.
And this is the layout of a gas turbine power plant. Okay, for the first is starting motor. Gas turbine not self starting. They required a starting motor to first bring the turbine to the minimum speed called coming in speed, and then low pressure compressor is LPC. The purpose of the compressor to compress the air. Air from the atmosphere is thrown into LPC and is compressed. And then to intercooler. The air after compression in the LPC, low pressure compressor, is hot. It is cooled by the intercooler. The intercooler is circulate with cooling water. And then go to the HPC. It is a high pressure compressor. The air from the intercooler enters the HPC where it is further compressed to a high pressure. And then regenerator. Okay, the air entering the combustion chamber. For combustion, must be hot. The heat from the exhaust gases is picked up by the compressed air entering the combustion chamber. Okay, and then combustion chamber, the fuel get ignited because of the compressed air, and then the fuel along with the compressed air is ignited sometimes with a spark plug. And then we go to HPT. It is a high pressure turbine. Okay, in the beginning, the starting motors run the compressor shaft, and then the hot gases, product of combustion, expand through the high pressure turbine. And last is we go to LPT. LPT, the purpose of the LPT is to produce electric power. LPT is a low pressure turbine, and then LPT to a generator.
Assalamualaikum warahmatullahi wabarakatuh, and a very good morning to my respected lecturer, Mr. Kiwizam. My name is Anis Asrar bin Muhammad Ithnain. My metric number is F2017. And as for the conclusion and summary, the combustion gas turbine being installed in many of today's natural gas fueled power plants are complex machines, but they basically involve three main sections, which is the compressor, which draw air into the engine, pressurize it, and feeds it into the combustion chamber at speeds of 100 of miles per hour. The second one is the combustion system, typically made of a ring of fuel injectors that inject a steady stream of fuel into combustion chambers where it mixes with the air. The mixture is burned at temperature more than 2000 degrees. The combustion produces a high temperature, high pressure gas stream that enters and expands through the turbine section. The turbine is an intricate array of alternate stationary and rotating aerofoil section blades. As hot combustion gas expands through the turbine, it spins and rotating blades. The rotating blades perform dual function. They drive the compressor to draw more pressurized air into the combustion section, and second one, they spin a generator to produce electricity. Thank you.